Hello, my name is Dr. Steele, and welcome to Steele Mathematics, where lessons in Algebra 1, Geometry, Algebra 2, Pre-Calculus, and Calculus are taught. And today, we're going to talk about circles. Now, I'm going to start this lesson with a single point. So here, we have a single point showing. And what I'm going to do is I'm going to draw points that are equidistant from this given point. Like these 3 points right here, they're all the same distance from this given point. And I'm going to draw some more. We have 3 more points, 3 more points. We got some more points, and more points. And as you can see, all those points that are equidistant to that point, those points form a circle. And that's what a circle is. It is a set of points that are equidistant to a given point. That given point is called the center. So for example, P would be the center. Now, we mentioned that all those points of the circle are of equal distance. And that distance is called the radius. So, segment AP and segment BP are radii, which is plural for radius. A circle is named for its center. Therefore, this circle that you see now is called circle P. And as you can see, there's the symbol for it. It looks like a bullseye. So now we have the radius. I want to introduce to you another line segment that pertains to the circle. But first, before I do that, there's a theorem about all radii. And all radii are congruent. And that theorem's true because, well, remember, the radius is that common distance. All the points on the circle are equidistant from that circle. So all radii are congruent. So therefore, segment AP is congruent to segment BP. So now we have what is called a chord, which is a line segment such that both endpoints are on the circle. So again, you see 3 chords: segment MN, segment AB, and segment IJ. So all 3 of those are chords. But let's turn our attention to segment AB. Notice that segment AB contains the center of the circle. Therefore, chord segment AB has a special name. It is called a diameter. So the next theorem, a radius is perpendicular to a chord if it bisects the chord. So a radius is perpendicular, meaning that the radius makes a right angle with the chord. If that happens, it bisects the chord. Therefore, its segment EP is perpendicular to segment CD if and only if segment CO is congruent to segment OD. And the reason why segment CO and segment OD are congruent because segment EP bisects segment CD. Next, we have a secant. It is a line that intersects a circle at exactly 2 points. And we're talking about this point and this point, A and B. So therefore, line AB is a secant. Now, don't get it confused with line segment AB. Line segment AB is a chord. Line segment AB would just be this part, okay? But the line that goes through the circle at these 2 points would be a secant. So now we have what is called a tangent. A tangent is a line that intersects a circle at exactly 1 point. And that 1 point is called the point of tangency. So as you can see, line MN intersects the circle at Q. So line MN is a tangent and Q is a point of tangency. Q is that 1 point that the tangent intersects the circle. So now we have a theorem. A radius that intersects a tangent at the point of tangency is perpendicular to that tangent. In other words, if the radius intersects a tangent at the point of tangency, then that radius makes a right angle with that tangent. Therefore, segment PQ is perpendicular to segment MN. Finally, we have one more theorem. Two chords are congruent if and only if they are the same distance from the center of the circle. Same distance. What it's saying is line segment AB is congruent to line segment CD if and only if line segment IP is congruent to line segment QP. So line segment IP and line segment QP are the distances from the center. So now I think we're ready to look at some examples. Let's say you are to classify each of the following as a center, chord, diameter, point of tangency, radius, secant, or tangent. So let's look at line segment AB. So here's line segment AB right here. Line segment AB intersects a circle at E. Therefore, line segment AB is a tangent. Next, we have point F. Okay, so there's point F right here. And as you can see, line segment BC intersects the circle only at F. Therefore, F would be a point of tangency. All right, next we have line segment DG. Line segment DG, that's this line segment right here. Line segment DG. Both the endpoints are on the circle. That makes line segment DG a chord. So finally, we have line segment EK, which is this line segment right here. This is from the center to a point on the circle. That's a radius. All right, let's say you have to find the missing measures. On number 5, you have one radius is 13, and you have to find the other radius. Well, they're both radii. They are congruent. Therefore, if one of them is 13, that means the other is 13. All right, number 6, you have a diameter and a tangent. You can also say that a radius intersects the tangent at the point of tangency. Remember that if a radius intersects a tangent at the point of tangency, that means it is perpendicular to that, meaning it forms a right angle. Therefore, it is 90 degrees. All right, number 7, you have a diameter that is 22. Now, a diameter is made up of 2 radii. The whole diameter is 22. So if a diameter is 22, that means each of the 2 radii is 11. Therefore, the length of that radius is 11. All radii are congruent. Finally, it seems that we have a triangle. One side is 13, another one is 12, and they ask for the third side. But here, one of the sides is the radius, and we have another side that is a tangent. And remember, a radius is perpendicular to a tangent, which means this is a right angle, meaning that this triangle is a right triangle. You're given 2 sides of the right triangle. You're asking for the third one. Therefore, you will apply the Pythagorean theorem, meaning that this side is the hypotenuse and the other 2 sides are legs. Therefore, a square plus 12 square equal 13 square. So now 12 square is 144 and 13 square is 169. Subtract 144 from both sides and you will have a square equal 25. We take the square root of both sides and we have a equal 5. Therefore, the solution is 5. This is the introduction to the circles and the lines and line segments that pertain to the circle. Remember that all radii are congruent. If a radius intersects a tangent, it is perpendicular to that tangent. If a radius bisects a chord, it's also perpendicular to that chord. And of course, if 2 chords are the same distance from the center, they are congruent. Those are the main points I want you to know from this video. I hope that you have a wonderful and blessed day.